Okay, section 1.R.3, addition and subtraction with fractions. Okay, so this is the second lesson that you will see in Hawks. So if you click on section 1.R.3, you should be able to find these problems here. I took the problems directly from Hawks, so hopefully they will look very similar to what you see. Okay, so let's quickly go over a couple of terms that we should know. Terms that we should know. The first would be numerator. It's a fancy way of saying the top of a fraction. And denominator, which is another fancy term, meaning the bottom of a fraction. Okay. And we want to make sure in this lesson in particular that we find what we call the common denominator, which just means when you have more than one fraction that the denominators are the same. Okay, so for instance, 1/3 and 4/3, right? These are fractions with common denominators, unlike 2/3 and 1/8, right? Two different denominators, no go. Okay, so we're going to add and subtract fractions. It's important that when adding and subtracting fractions that they have the same denominator. You want to be able to compare two like things. All right, if you're adding something or subtracting something, you want to make sure you're dealing with the same quantities. All right, so let's start off with the first example. Again, this is coming directly from Hawks. Compute the difference indicated and then simplify your answer. So 2/3 minus 2/5. 2/3 minus 2/5. Okay, notice the denominators are not common, right? We have a 3 here and we have a 5 there. So we want to change the fractions without actually changing their values. Okay, we want another representation for 2/3. So what I'm going to do is off to the side here, I'm going to write out 2/3. And I'll write that out in red. And I want to change it some sort of way by multiplying it by a fancy 1, right? This is a 1 here. All right, wrote a little 1, but we don't need that there. Okay, and that's going to give me a new version of the fraction. And hopefully that has the same denominator as off to the right here, our blue number here. So 2/5, and we want to have a fraction common denominator, so we're going to multiply by a fancy 1, yada, yada, yada. All right, so 3 and 5. We want to think of a number that 3 and 5 both go into. Okay, well, the inefficient way to do this is to write out 3 and write out 5 and then count by 3s. 3, 6, 9, 12, 15, 18, 21. Count by 5s, 5, 10, 15. Up 15 would be our common denominator. Okay, that's the inefficient way to do it. There are other ways to do this, but typically you can just think this through and come up with a number, right? So 3 goes into 15, 15, and 5 goes into 15. So the question now becomes, what do I need to multiply? What number goes here and here? That'll give me a 15 there, and that's going to have to be a 5. So I'll multiply 3 times 5. That will give me 15 on the bottom. Right? 3 times 5 is 15. And we said that this has to be a fancy 1. So another way to write out 1 is 5/5. Right? 5/5 is 1. So we're really not changing 2/3, the number, right? The value, we're just changing the way it looks. All right, so 2 times 5 is 10. So 2 times 5 is 10. All right, so 10/15. And think about that for a second. 10/15, if you were to reduce that, you can divide the top and the bottom by 5, and that would give you, right, 2/3, okay? So we're good. Now, same thing on the right here. So 2/5, we need a 15 on the bottom. 5 times something is 15. That something is 3. In order for this to be a fancy 1, we have to make sure the top is 3 as well, because 3/3 is 1. All right, so 5 times 3 is 15. 2 times 3 is 6. So there's our two new fractions. Let's keep the colors consistent here. Okay, so we have 10 over 15 minus 6 over 15. Okay, now what I don't want you to do is say 10 minus 6 is 4 and 15 minus 15 is 0, right? No, don't do that. So common denominator, you have 10 fifteenths minus 6 fifteenths. You're left with 4 fifteenths. And so that would be my answer, 4 fifteenths. All right, let's do another example. All right, here we go. Here we're adding two numbers together, 16 over 22 plus 4 over 22. Okay, we kind of catch a break here because 22 and 22, those are common denominators. Okay, and so I don't have to change anything. I can just add them up just like I see them. 16 over 22 plus 4 over 22 is 20 over 22. Now don't forget about the simplify part, right? 20 over 22 is not simplified. Okay, I can actually divide each of these by 2. 20 is divisible by 2. That's 10. 22 is divisible by 2. That's 11. So 10 over 11 is my sum. All right, 11 over 36 plus 6 over 63. Now this is just a mean question. I don't know why they would do this to you, but whatever, we're going to deal with it. All right, so 11 over 36, 6 over 63. These are not common denominators, so we need to figure out a common denominator. All right, so I didn't want to do this to, whatever, we'll do this anyway. So 36, start off with 36. All right, what I'm finding here is called the prime factorization. In other words, I want to find something times something that equals 36. And there's a variety of combinations. We can do 4 times 9. We can do 6 times 6. 2 and 18. Let's just do 6 and 6. Okay, and then each 6 can be broken down into 2 times 3 and 2 times 3. All right, so 2 times 3 times 2 times 3. If you multiply all those together, it equals 36. Okay, so 36 is 2 times 2 times 3 times 3. All right, now let's deal with 63. Okay, 63 is 3 times 21. 21 is 3 times 7. Okay, so 3 times 3 times 7 is 63. We do want to be, or let me point out something real quick. Why didn't I continue down here, right? Because technically I could break down 3 into 1 times 3, right? But notice I'm not actually breaking it down at this point, right? I'm stuck in this infinite, yeah, anyway, I'll be here for a while if I try to do that. So instead I will say it's a prime number, so I'll stop there, prime number, stop there, prime number, which means I can't break it down any further than 1 times itself. Again, okay, so to find my common denominator, what I'm going to do is combine these two denominators, okay? So let's see what they have going on here. 36 has 2, 2, 3, and 3. Now I want to look over at 63 and figure out what does 63 have that 36 does not have. Right? Well, it has a 3, right, which we're covered, but it also has this extra 7 here, so I need to add that extra 7 in. So what is that? 2 times 2 times 3 times 3 times 7 is 252. So that's going to be my common denominator. All right, all that work just to find the common denominator. All right, so this will always work if you're trying to find one. a common denominator, but there we go. Okay, so 36. As a matter of fact, let me just kind of scooch this down. So off to the side here, 11 over 36 needs to be changed into something over 252. So I'm going to multiply it by something. 36 times something is 252. Okay, well that would be 7. And remember, the top has to match the bottom, right? So 36 times 7 is 252. 11 times 7 is 77. So we have 77 over 252. Okay, now we need to change 6 over 63. It needs to multiply times something. So that way I can get 252 in the bottom. Okay, and that's going to be 4. By the way, if you wanted to figure out exactly how to get that number, just look here. If I'm trying to get this, what's missing? The 2 and the 2, right? 2 times 2 is 4. That works here as well. What is it missing to get this? It's missing the 7. Okay, so 4. Okay, 63 times 4 is 252. 6 times 4 is 24. All right, so 77 plus 24 is 101 over 252. Okay. Now we need to try to simplify that, if at all possible. Let me think about that for a second. It's not divisible by anything. There we go. All right, so 101 over 252. What a mean question. Okay, oh, this is a fun one. All right, so I guess if they're going to be mean, they follow it up with a nice one. So 5 over 13 minus 2 over 13. We're happy because we have common denominators. So we're just really doing 5 minus 2. That's just 3, as far as I know. So 3 over 13 is my difference. Okay, they're back to being mean again. Okay, so 37 over 100 minus 198 over 1,000. Okay, so this one's actually not too bad because I just need to add a 0 here, right? And just add a 0 right there. Okay, so then what am I really doing? 37 over 100. I want it to be 1,000 on the bottom. So what am I doing? I'm multiplying it by 10 over 10. All right, 100 times 10 is 1,000. 37 times 10 is 370. I'm getting lazy with my colors here. We have 370 over 1,000. I didn't change this one at all because I didn't have to. Okay, so 370 minus 198 is 172 over 1,000. I'm going to double check that real quick, although I feel pretty good about it. 172, right? Okay, and then 172 over 1,000. Okay, I know I can simplify that. How do I know? Well, I have an even number here and here, right? So if two even numbers, you can divide by 2. So I'll divide by 2. Okay, and if I divide that by 2, that's what, 86.